Hello everybody, thank you for joining us for today's webinar. My name is Faze and I'll be the moderator today. So for today's webinar, we're discussing culvert rehabilitation using Uponor's Weholite. Our speakers today are Mark Lister and Joe Nagy. So before we begin, a couple housekeeping rules. The webinar content and PDA certificates will be emailed to all attendees if they state the duration of the whole webinar. All questions will be answered by email and sent to the audience accordingly. If you have any additional or detailed questions you'd like to ask, please email us at nainfra-sales@uponor.com. We'll also give you our emails of the speakers today if you have any specific questions for them. So today's speakers and contributors are Mr. Mark Lister. Mark is the Regional Sales Manager for Ontario, Manitoba, New York, and New England states. He's been with Uponor for just over 15 years now, and he's responsible for Weholite engineering, specification, and promotions to DOTs, municipalities, and counties in the culvert, wastewater, CSO, SSO, conveyance, and stormwater markets. Mark has over 25 years experience working with engineers, contractors, and owners on construction and design solutions projects. We also have Mr. Joe Nagy. Joe is the sales engineer for the Great Lakes and Mid-Atlantic states. He's responsible for culvert lining and engineered systems. He's worked with engineering consultants as well as state and local agencies. And he also has over 25 years experience working with engineers and contractors within the engineered system. So in today's agenda for our webinar, we'll be discussing, Mark will do an intro to Uponor and Weholite. We'll look at some engineered systems overview, pipe design, material testing, the benefits of relining versus replacing, Weholite Reline system, Reline Steps, other Reline considerations, and then we'll look at some projects in the past that Uponor has been involved with when it comes to culvert relining and rehabilitation. So with that being said, we'll start our webinar. I'll hand it over to Mark Lister.
Thank you, Faze, and welcome everybody to our webinar today. Just going to give you a little bit of background on Uponor Infra. Uponor Infra was formerly KWH Pipe. We've been producing plastic pipes in North America since the 1960s. In 2013, the company was renamed Uponor Infra following a merger between KWH and Uponor. Uponor manufactures polyethylene pipe and fabricated engineered systems for use in a number of markets, and we'll talk about a number of those as we go through the presentation, and then specifically with regards to culvert rehabilitation. Uponor is an ISO 9001 certified manufacturer, and we do have third-party certification that we manufacture to those standards. We have 2 plants in North America that supply the U.S. and Canada. The Weholite pipe we will be discussing today for culvert rehabilitation has been available since the late 1980s. Prior to jumping into the main part of the webinar, or culvert rehabilitation, we'd like to give you a brief overview of Weholite and its applications. Since we have both U.S. and Canadian attendees, we'll be making reference as much as possible to both imperial and metric measurements. And if we miss out on that, please don't anybody feel offended. So what is Weholite? Weholite is a structurally reinforced profile wall high-density polyethylene pipe that is manufactured to the ASTM F894 standard. Joints can be threaded, field welded, or mechanically coupled. It has a severe corrosion and abrasion resistance. It's lightweight and comes in diameters from 18-inch or 457 millimeters to 132-inch, which is 3350 millimeters, and in length up to 50 feet long, depending on the size and specific project conditions. Weholite is manufactured by extruding a box profile and winding it onto a mandrel, as you can see here on the left-hand side of the photo. As the profile sections come side by each on the mandrel, they are extrusion welded on the inside and outside. So the pipe could literally be made to any lengths if you had a way to transport them. And in fact, we have in the past extruded right into a water source, for instance, and shipped or tugged 200, 500-foot long pieces of pipe to where they need to be. So the photo on the left shows a larger diameter wheelite coming off of the mandrel. On the right is a cross-section of the pipe where you can see the factory welds, which are the thinner welds you see in that photo, and the weld in the middle is a full wall field weld that would be used for higher pressure applications. This sketch shows the geometry of the box profile and how each is extrusion welded together. This geometry of boxes will vary depending on the diameter of pipe that is being utilized, from the smallest to the largest. Here you can see a side view of a large diameter pipe being manufactured. An automated saw will cut the pipe to the specified lengths for order or to standard sizes for product we keep in stock. Here you can see wheelite box profiles that can also be used to make flat panels instead of pipe. Instead of the box profiles being wound around the mandrel, we extrude the profiles onto a flat surface. The profiles are then extruded welded on the ID and the OD to make flat panels. What you see in this photo is 6 individual panels that are stacked on top of each other for precision cutting to uniform lengths. These panels are used in many of our fabricated engineered systems, such as end panels for storage systems, baffle walls, manholes and pump station tops and bottoms, and modular systems for a variety of applications. Uponor is currently investigating the viability of providing wheelite modular structures for the rehabilitation of concrete box culverts, wooden box culverts in the transportation industry. So let's take a quick look at some of our engineered systems, and then we'll move into the meat and potatoes of the webinar, which is the culvert rehabilitation. Wheelite engineered systems combine the strength and versatility and durability of Weholite and Wehopanel to provide fabricated systems with 100-year plus design life, and this is based on 30 years of design and fabrication experience. We do this into a number of different marketplaces, whether it be transportation industry using the culvert rehabilitation and new culverts, stormwater detention, CSO storage, pump stations, rainwater harvest, geothermal vaults, wastewater treatment. We do a lot in the hydroelectric conveyance, penstock business, and a lot in the irrigation business also, as well as manufacture a number of custom structures. Really is limitless by your imagination. And we're having there we go. Had a bit of technical difficulty there. In these collages, you can see some header assemblies, storage systems, tanks, modular systems, retention systems, and a number of different chambers, as well as some manholes, reducers, Ys, Ts, elbows, pump stations, and just about any combination of the above that you can think of. This actually really shows off our fabrication capabilities. Before we get into the culvert rehabilitation, let's discuss a little bit about Weholite pipe design. When looking at pipe design, it's important to note that the solid wall HDP and profile wall pipes use different methods for measuring stiffness. Solid wall pipes and many other pipe materials use pipe stiffness, such as like 46 PSI, while profile wall uses ring stiffness, or it's called the ring stiffness constant. Pipe stiffnesses are good for smaller diameter pipes, but not so applicable to larger diameter pipes, such as profile wall pipes. There are simply two different ways of measuring stiffness. The correct method for the type of pipe being specified should be used. Now on the screen you can see a screenshot of ASTM 2412, which deals with pipe stiffness, and then ASTM F894 that deals with profile wall. And as you can see there, the stiffness in 2412 is based on the force or load measured at a prescribed deflection position of the plate moving at a prescribed speed on a sample of prescribed length, whereas F894 is developed to address handling of larger pipes. And it's a stiffness measurement that is weighted for the size. The ring stiffness load is divided by the deflection as a percentage and then divided by the sample length in feet. So very different ways of measuring stiffness. The design requirements for pipe manufactured to ASTM F894 standard are quite stringent. For example, this photo illustrates that ASTM F894 flattening test or parallel plate test for qualification to the F894 standard. The pipe must be flattened to 40% of its ID. It has to show no splitting, cracking, breaking, or separation of the pipe walls or bracing profiles. This comes into play within our culvert rehab part when you see that we can ovalize pipe for ovalized culvert rehab applications. We can provide third-party accredited certified testing that Weholite meets the required standards. This type of documentation should be part of any specification. We also do our own quality control testing, and as part of our ISO 9001, as well as our own internal quality control. We do destructive testing on the pipe and pipe walls. We can do a tensile strength, and in the photo on the left, you see we've situated a section of pipe with 2 welds, and then the profile section in the middle, and then we do a tensile strength test. You can see that that wall of the pipe yields at 2,900 psi or greater, while the factory welds, or if they were field welds also, would maintain intact. And for complete design information, the Handbook of Polyethylene Pipe, specifically Chapter 6, should be consulted. It can be found at the Plastic Pipe Institute website, and you can also see a number of other sections of the PE Pipe Handbook, whether it be standard specifications and test methods, underground installation methods. All that you need is right there. You can also go to our Uponor website for design assistance. All you need to do is register for our online calculator where you can perform a number of different design calculations, whether it be buried pipe design, gravity flow, buoyancy calculations, wall buckling. We also have a full engineering department that can assist with your design questions. Now that we've given you a brief overview of Weholite and Uponor, let's get to the culvert rehabilitation with Weholite portion of the website, or the webinar, sorry. And what we want to look at, first of all, is really why reline and not dig and replace. Culvert relining or slip lining is called a couple of different names. We call it slip lining, we call it relining, depending what part of the country you're in. You'll be familiar with one or both of those terms. So why reline and not dig and replace? Well, relining is generally 30 to 50% less expensive. It's up to 10 times faster. It prevents future pavement problems. You can avoid traffic disruption and congestion. You maintain or increase the flow capacity through the barrel of the pipe. It's an environmentally sound option. You're very little disturbance to the stream beds and construction debris. And you can save upfront dollars and improve the life cycle of your system. Let's for a moment, though, focus on pavement problems. You can see that I've on the screen that pavement problems and traffic disruption are in bold. Most of us have experienced driving along the road and driving over a newly paved cutout across the road that has a small dip or a bump in it. This is normally, what this normally is a culvert that's been replaced. And the uneven roads are a safety hazard. And this condition can be avoided when relining. It's very difficult for the contractors to keep that cutout at the same level as the existing road. You would have noticed that we also highlighted traffic disruption. The social and financial costs associated with traffic disruption and detours has become a science unto itself. In 2013, traffic congestion cost the U.S. economy $124 billion, and this is projected to increase 50% to $186 billion by 2030. The cumulative cost over the 17-year period is projected to be $2.8 trillion. As a Canadian example, from the City of Toronto, shows an annual estimated cost of $3.3 billion to commuters and $2.7 billion to the economy. And this is estimated to balloon to $7.8 and $7.2 billion respectively by 2031. And if you take our two examples and look at this pie chart from the Federal Highway Administration in the U.S., where work zones represent 10% of traffic disruptions and congestion, this would translate to $18.6 billion by 2030 related to work zones in the U.S. and $1.5 billion in the GTA area, for instance, in Canada. Anything that can be done to reduce work zones will obviously reduce these staggering numbers. So let's look at the Weholite Reline system itself and how rehabilitation can save you money and extend the life of your existing culverts for years to come. The Weholite Reline system is available in sizes from 18-inch, as mentioned before, 457 millimeters to 132, 3350 millimeters ID, and in stock lengths from 16.5 or 5 meters, 25 feet or 7.6 meters, and 50 feet, 15.2 meters, depending on the diameter. Custom lengths are also available. When the right-of-way allows you to use the longest length possible, it can drastically reduce the installation times due to less joints. The Weholite Reline system can be used for round, oval, and odd-shaped culverts. So where should you use Reline? Well, Reline should be a consideration when the hose pipe is deteriorated but generally round and stable, when the culverts are under deep fill, where busy roads cannot be detoured or closed, when a long-lasting solution is required, and when you want to provide more for your taxpayer dollars. The deeper the fill, the greater the savings, obviously, and the busier the road, the more rehabilitation should be considered due to the social costs and safety considerations associated with traffic stoppages, lane closures, and detours. Relining is the solution for the longest lasting, most cost-effective remedy to your culvert problems. Most DOTs require the liner pipe to be designed as if it were a direct bury pipe. Uponor can provide design assistance and guidance regarding the correct RSC to be used and grout recommendations. Grouting is the key to any successful installation. When we talk about requiring it to be designed as direct bury, most DOTs and Ministry of Transportations require that the pipe act as if it is direct bury. So when we do the design calculations, those are done without any consideration for the hose pipe and any structural integrity left in the hose pipe. We look at flow comparisons, and the other thing you want to consider is hydraulics. The roughness coefficient for hose pipe material must be compared to that of the Reline pipe when considering hydraulics. First, if we look at this general example of pipe flowing full through the barrel capacity when acting as a sewer. In this example, we want to determine the correct size to convey 32,000 US gallons per minute at a 3% grade. Three pipe materials we're considering have the following mannings in. Weholite is 0.01, concrete 0.014, and CSP or CMP at 0.024. And based on that mannings for each of these three materials, the size required would be 42 inches for Weholite, 48 inches for concrete, and 60 inches for a CSP or CMP pipe. We also want to keep in mind that HDP is a homogeneous pipe that has the highest abrasion resistance of any pipe. This means when the pipe does become abraded, all you're doing is exposing more of the same HDP material. Unlike CSP or concrete, the mannings is virtually never affected. This means over the life of the pipe, the flow will remain unchanged. And this is obviously very important in a culvert situation. The deterioration of the inside affects the flow rates and it can allow debris to get caught up and cause blockages, as well as reduce your overall flow rate through the pipe just from wear and tear. In a culvert situation, we know that flow is governed by inlet and outlet geometry, so it may also be necessary to consider loss of cross-sectional area when reducing the inlet and outlet of the pipe with relined pipe. In many cases, the existing culverts have been over-designed and the reduction may not matter. In other cases, it may be critical to not have backwater conditions that exceed the existing conditions. Although we are reducing the diameter, the reduced mannings can allow the water to move better through the culvert and thus helping to reduce this backwater situation that may occur. Further on in the presentation, we'll see some examples of ways that you can increase cross-sectional area to be closer to the host pipe's original condition, should it be required, and ways to slow down the flow through the barrel if necessary, as this can cause problems at the outlet and also if the water is moving too fast through the pipe. But just to give you an example of flow comparison, this flow comparison chart can be used to help determine what size culvert will fit and meet your needs from a simple flow through the barrel perspective. As an example, if we look at a nominal size CMP of 84 inches or 1,800 millimeters, and based on flow alone, this could be relined with 66-inch or 1650 millimeter Weholite and have 32% greater flow. In reality, we recommend a 72-inch or 1,800 millimeter culvert that would be recommended size for the purely fitting point of view. This would reduce the amount of grout that's used and therefore reduce the overall cost. Some of the other conditions that must have solutions when considering reline are included in some of the reline steps. When looking at a culvert and reline steps, you have to look at the assessment and inspection of the culvert, sizing, methodology, cleanout and site preparation, pipe installation, constructing bulkheads, and grouting. Let's take a look at the steps to a successful culvert rehabilitation project as we go through the next few slides. During the assessment, there's a number of things to consider, such as, is the culvert a candidate for rehabilitation overall? What is the level of corrosion? Has it collapsed too much to reline? Are there other factors such as deflections, large bends, or any other restrictions in the host pipe that would prevent relining? In these two photos, you can see some rusting metal taking place. You can see a bit of collapse in the right-hand side. Just because the pipe is starting to collapse doesn't necessarily mean that it is not a candidate, or just because it's rusting. There are a number of things that can be done to still make these candidates for rehabilitation. Some common conditions that you may see during your assessment are such as here, where you get this corroded bottom or a fingering effect. This is actually still a candidate for relining, providing the rest of the structure is still sound. By repairing the invert to prevent the grout from escaping, you can easily still reline this pipe. Next thing you want to consider is, well, what shape do I use? You've got a round pipe, you've got an oval pipe, maybe you have an odd-shaped pipe and you want to know what would fit in. Once you've determined that the condition of the culvert is a good candidate, then you need to decide which one of these you want to use and which size. When selecting the size of the reline pipe, you must ensure the OD of the reline pipe fits inside the host of the pipe, while at the same time meeting your hydraulic needs. Since grouting is the key to transferring load from the host pipe to the reline pipe, a good rule of thumb is that the OD of the reline pipe is 5 to 10% less than the ID of the host pipe. And Joe will talk about grouting further on and the importance of grouting through the entire length of the culvert. If you need to ovalize a Weholite pipe, as I mentioned earlier, we can do ovalization and provide assistance with ovalized dimensions. Our literature provides charts showing dimensions of the pipe that's been ovalized to 20%. Obviously, you can do 5%, 10%, or somewhere up to there. But should you need something that's more than 20%, you need to contact your Uponor representative and to confirm suitability of the application. And and keep in mind that these are 20% from the OD, or OD dimensions. As far as methodology is concerned, you need to also decide on your methodology on how you're going to utilize, what methodology you're going to utilize for a successful project. Are you going to push or pull maybe a combination of both, the new culvert into the host culvert? Are you going to use threaded or welded connection? Are you going to provide, you need to look at providing a suitable area to complete the necessary joining and installation to ensure that the installation goes on without problems. In the photo on the left, you can see that the contractor has decided to push the pipes in using the strap attached to his backhoe. In the photo on the right, you can see a contractor has used gravel to create a good level surface for him to work from and be able to join the pipe. In these two photos, you can see how the contractor has decided to use rails far outside the culvert for the ease of joining and pushing in the pipe. These are planning decisions that really should be made prior to beginning your project. And Joe will talk about inserting the rails and some of the reasons for putting rails in further on in this section of the webinar. Now that you've done your assessment, your size and methodology, and worked out, it's time to work out your clean out and preparation needs. The first step is to clean out all debris, silt, rocks, etc. Check to make sure there are no deflections, impingements, minor collapses in the hose pipes that may need to be jacked back into place, and no invert problems that were previously not apparent due to the silt and debris that was in the bottom of the culvert. Once the clean out is complete, you must prepare the culvert for receiving the reline pipes. When possible, rails should be installed roughly at the 5 and 7 o'clock positions. Lubricating these rails will reduce the coefficient of friction and make pushing the reline pipe in easier. The rails should not be continuous. Spaces must be left at regular intervals to ensure that the grout can make its way around the entire pipe during the grouting process. When minor bends need to be navigated without the use of elbows, a side rail should be used to prevent the leading edge of the reline pipes from getting hung up on the CMP corrugations while advancing the reline pipe. For smaller pipes where getting inside is not possible, rails can be strapped to the OD of the pipe if space permits between the host and the reline pipe. And in some cases, it's just not possible to put any kind of guidance or blocking in place, and due to the size of the pipe and not being able to get into the pipe. So you just have to be a little more careful when you're pushing the pipe through that it doesn't get hung up on the corrugations or any unlevelness if it's a concrete culvert. Then you need to look at installing grout tubes. And grout tubes are usually installed at varying lengths to ensure the grout gets completely around the entire pipe. Typically, they use 2-inch PVC tubes are being used. Multiple grout tubes are used down the length of the culvert to ensure flow coverage between the hose pipe and the liner pipe and can accommodate multiple lifts if necessary. In some cases, designers or contractors may choose to use grout ports instead of grout tubes, either for preference or due to job site specific conditions. The design engineer should propose the grout port locations in their plans for the project or consult Uponor's engineering prior to the plans being issued for the tender. These are a couple of ways to get grout in. You can also get grout in from a chimney, from pouring a hole in the top of, let's say, the embankment or in the median, if that works, and then you can actually just drop in grout from the top also. As with rails, and when possible, blocking should be placed prior to placing the pipe to resist buoyancy during grouting and keep the pipe on grade. Here you can see a couple of different forms of blocking techniques. In the top left photo, the contractor has chosen a system that spans the obvert of the pipe. In the bottom right, the contractor has chosen to place blocking at 10, 12, and 2 o'clock positions. You can see the grout tube going through on the crown of the pipe. As with guide rail, space must be left for the grout to be completely surround the reline pipe. An alternative way to block the pipe is the use of jacks to the top of the reline pipe to hold the pipe down, as you can see in these photos. As with rails, blocking can be strapped to the OD of the reline pipe for smaller sizes where it's not practical to attach to the inside of the hose culvert or use this type of a jack method. So now that we've completed the clean out preparation and preliminary things you need to do for Culvert Reline, I'm going to turn it over to Joe, and he's going to take over to discuss installation, some other considerations, and review some project snapshots. So with that, Joe, I'll turn over the controls to you.
Okay, thank you, Mark. Okay, so we have pipe installation and some things that we are going to talk about through this part of the presentation are the types of joints that are available, which is threaded and fused joints or welded. We're going to talk about whether we're going to push and pull the pipe into place. We're going to talk about the process of just repeating that. We're going to talk about constructing the bulkheads, grouting, head walls, and as Mark said, we're going to go through some project profiles rather. So joint configurations, we have threaded joints and we have welded joints. So in the planning process, you've already determined which joint's going to be utilized for your project. So you're going to determine that with the engineer or with your maintenance crew, whether you're going to use a threaded or for welded joints required. So on the threaded joint system, this is a contractor-friendly sand or silt tight joint, which is available in all sizes, 18 up to 132 inches. Due to the spiral manufacturing of the profile wall pipe, this process of the Weholite, we're able to remove the outer skin, and when we do that, we expose 2 to 3 ribs, and then we do that on the ID of the pipe as well, and that allows us to create what we refer to as a natural threaded joint. This can be done in the field by the contractor if need be. We do generally send this in the field prepared, but in the case that there would be a problem in the field, this can be also constructed in the field by removing that outer and inner skin to recreate that joint. If you're using a threaded joint, you in most cases may want to address that joint with some type of a wrap to prevent any grout during the grouting process that we're going to talk about here later on of intruding in through that joint during that process, because grout is a very, very fluid type grout. So you may want to think about that. When we go to our welded joints, we look at welding from the ID on 36-inch diameter and up, and from 33-inch and down, we can only perform a weld on the OD. So if the welded joint has been planned as the joining method, the OD and the ID, you have to determine how that's going to be performed in the field and what the contractor is going to be responsible to do there. The joint's going to need to be maintained in a dry condition and to perform the welding. We always have to have a dry condition and contaminant free. So the welding can be performed by an Uponor technician or other trained extrusion welding technicians that most likely should be approved by the engineer prior to the project construction. So on a welded joint, you'll see that there's a band here. We want to talk about that. When the welded joint is selected or necessary, the pipe will come with a 90-degree notch on the ends for lining the pipes up. And then the first step is, as they line that pipe up, now we're going to have to use an alignment band to hold that pipe in place. So as you see on the left there, that band is put into place, and that's going to help hold that pipe during the time that the technician is there. Now, this is also going to help keep from dust and dirt and actually even wind getting into that joint and contaminating that. So when the alignment band cannot be used on the smaller diameters, obviously, so contractors are going to have to take precaution in the field to address that and create a nice clean environment to be able to construct that weld, and then also to hold that pipe steady during that welding process. Now that we've covered the joining methods, we're now ready to talk about inserting the pipe, the Weholite pipe into the culvert that we're rehabilitating. So what the first step you're going to take is the first section of pipe is going to be placed approximately 3/4 of the way up into the hose pipe, and then you'll bring the next section of pipe in, and then the joint connection will be made, whether that's going to be a threaded joint or a welded connection. That's going to have to take place before continuing to insert the pipe, the liner pipe into the hose pipe. And once they can continue to do that, then they're just going to repeat this process, inserting the pipe, leaving about 25% of the pipe out of the hose pipe, and then bringing the next section of pipe in. There's several different ways to insert the pipe in to the hose pipe, which you're going to see here in the next few slides and portion of the presentation here. So bringing the pipe up into the hose pipe, there's different methods. Contractor can use a strap, which he's going to basically, in most cases, he's unloading or lifting the pipe and bringing it into place with. And just simply by lifting up on that strap will tighten down on itself, and then he's able to swing that arm of that excavator and actually slide that pipe right up into the hose pipe. In some cases, as you can see here, in larger diameter applications possibly, you can see the contractor here has selected to use the excavator and the back of the excavator, getting much wider stance against the pipe and being able to push on the pipe, and he's walking the pipe up into the culvert that way by just bringing the excavator back against the pipe. In some cases, depending on the size and the length of run, you may have to use equipment that's greater than what we saw there, or a method rather than different than the strap, different from using an excavator. And then what I'm getting to is here that we're using, the contractor on this project is using an excavator. So he's able to push with this bulldozer to be able to push the pipe in. And sometimes it takes two bulldozers. So in this case, and we will go over this project, it's one of our profiles, but this happened to be a 132-inch Weholite pipe, and this was a 1,000-foot run of pipe. So when you're looking at this size pipe, the weight is fairly great, and between the friction and the hose pipe and the length and all those factors coming into play, it took, in this case, for the last 200-plus feet of pipe, it took actually, for those that are familiar with equipment, a D4 and a D5 dozer to be able to apply enough pressure to finish pushing this 1,000 feet of pipe into place. Now, when you're pushing and applying this amount of pressure onto the pipe, we have to think about that the end of the pipe and what we're going to do about protecting that end, whether it's a threaded end or going to be a welded end. We're going to have to protect that. So in this case, you can see the excavator lowering in a large plate. That's a welded plate that the contractor constructed to be able to place over the end of the pipe so that he could apply the pressure with the dozer blade, hence not applying any point loading or damaging that end treatment of the pipe. So as you can see here, they lower the plate in. The plate is placed over the end of the pipe for protection of the end treatment, and before they begin pushing, and they're able to advance the reline pipe into the hose pipe by applying pressure to this steel plate or gate, if you would, that they've constructed without causing any damage to the end of the pipe. So probably a more common push plate that you might see in the field, much easier, less expensive, easier to construct in the field, is by just simply using some plywood and some framing material and be able to construct a plate box to set over top of the pipe here. And this works just as well and at much less cost and much easier for the contractor to construct in the field if he gets to the point where he's going to be required to use something to apply a greater pressure than he anticipated. So in some cases, it may be necessary that, depending on the site conditions, that can't maybe get equipment in or to push or to pull. So what we can do, or what can be fabricated, is what we refer to as pulling heads. These can be fabricated in the field by the contractor by simply cutting out wedges of the pipe, bolting on some type of a strapping apparatus so that they can cinch the end of that pipe down and create that bullet nose on there. And then with that, generally when they do that, if you can see in the slide to the right, that should have a hitch type connection on it. They're able to attach a cable to that and then pull the culvert through the hose pipe that way. Now, one note to make that if a pulling head is required, that will have to be determined prior to construction and going to the job site. That's a sacrificial piece of pipe. So for whatever length the contractor decides that he is going to do that, then we're going to have to add that to the length of the run of the culvert. Okay, so now that you have your culvert liner in place, you're going to have to construct your bulkheads. So once that pipe is in there, you're going to construct these bulkheads, and generally you're going to construct this out of concrete. The grout tubes that were placed in, as you saw in Mark's presentation, those must protrude out of the end of the bulkhead. Okay, as we move on and we build this bulkhead, or as we're constructing it, we have to install vent tubes. Those were not installed. Those vent tubes are just basically going to be just a little bit longer than the bulkhead itself. So those can be placed in at the time of building the bulkhead. We have to be able to have a way for the air to get out of the annular space to be able to allow the grout to flow properly throughout that annular space. Generally, the bulkheads are going to be constructed out of concrete, but most of the time we like to recommend that a non-shrink additive might be placed in there as well, because we don't want to see cracking. If there's any cracking in that bulkhead, then this grouting material can start leaking out throughout that process. Grouting is probably one of the most important steps of the reline process. This needs to be done for the entire length. This will ensure a good composite rehabilitation between the hose pipe that's effectively going to carry the traffic for years to come throughout this rehabilitation of this culvert. So we want to make sure that the contractor is either an experienced grouting contractor as well as installer, or that he subcontracts this out to a contractor that may specialize in grouting. Grouting can take the pipe and actually create deformations if there's too much pressure used. There's very a few factors that really need to be taken into consideration. We will, as you can see here, is a collapse resistance table that can be provided. And as far as grout lifts, Uponor also provides recommended grout lift tables based on grout density. That grout density most of the time is going to be confirmed or specified by the engineer of record. So you have a completed liner. Once the grouting is completed, you have a rehabilitated culvert that has extended the life of this hose culvert for many years. We've done this without excavation. We've done it with minimal traffic disruption, if any at all, and along with a great cost savings when compared to dig and replace. When we look at most of the culvert rehabilitation projects, they're generally on the average of 30 to 50% less than a dig and replace condition or process. Some other reline considerations. When relining, depending on the application or the area that you may be in, or the stream that you may be lining a culvert in, you may be looking at needing fish baffles or flow attenuators, something to help either silt up that bottom, slow the flow down, maybe a couple of different variables there. If fish baffles or flow attenuators are required, they're generally designed by the hydraulics engineer and fabricated by the manufacturer. The other another consideration. Okay. Another consideration for addressing the invert of the new liner pipe, possibly in place of fish baffles or attenuators, is to create a natural stream bed. And you can see they did that here by placing riprap in the invert of the culvert. Elbows and bends, which you may incur in your liner. Minor bends can be accommodated without the need for elbows. We are able to, that's one of the beauties of HDP pipe, that it does have flexibility. We also do overrising of this product as well. So we're able to the contractor should be able, in a lot of cases, if it's a minor bend, maybe say 15 degrees or less, he's going to be able to work that pipe around that bend without requiring any specialized elbows within the liner pipe. If elbows are required or bends, we can customize those. What that's going to do, though, that is going to require that the contractor work the project from both ends. Going to need to get that elbow or bend in place and then bring the pipe to it from both ends. And here you can see a nice close shot of a fabricated elbow. Lateral connections. In a lot of cases, you may have laterals that are running into the hose pipe. Those need to be identified prior to inserting the liner pipe, marked, lined off, and then once in place, in obviously in sizes 36-inch and up, where what we consider man entry, the contractor can now go in there and cut those openings out, bring those laterals, and put those laterals into place. Lateral connections. Any type of lateral connection is going to require that once that's cut in, you're going to have to seal it off and basically try to build from the inside out in most cases, or if it can dig down on the outside, be able to seal off around that lateral connection so that when grouting, the annular space, the grout's not finding its way through the opening around that lateral penetration. Some different designs and methods for inlet improvement. We can fabricate pretty much any kind of concentric fitting or in treatment that we need to, or that the engineer decides that hydraulically is required there to help to be able to maybe get that water down into that culvert a little more efficiently. Here's a few snapshots of inlet improvements. So extending the hose culvert out, cutting sections of the pipe down on slopes and riprap around that area. Going to help get that water into the culvert with less restriction. Again, they did the same thing on the bottom right corner, where you allow where you have your riprap that was placed in the bottom of the culvert. So by tapering the pipe, you enhance this invert and allow larger volumes of water to enter the pipe with less restriction. Another shot of an inlet improvement. And then there's other types of inlet improvements as well. Precast, prefabricated inlets and headwalls, as you can see here, can be supplied and provided and can be connected to the ends of our pipe. And here we're going to look at a couple different headwalls. Again, the pipe slope of the pipe, the length of the pipe was calculated so that they had enough pipe to cut those slope ends back and then place concrete around on that slope protection around there below their riprap there to prevent any erosion and anything eroding against the grouting or in the bulkhead or annular space of the pipe. And then here you can see a very extensive headwall design allowing for water to enter the two culverts here with much greater ease by being able to hold water and hold a large volume of water here and then not without restriction. So go to a few project snapshots. You can see some of the type of projects that we've been involved with. Here, this is a project on Highway 62 in Bancroft, Ontario, Ministry of Transportation, Ontario. This is a 78-inch culvert. Roadway was recently resurfaced, so that drove the design to use a reline to prevent the open cut of the new service, the new resurfaced road, while and minimizing traffic disruption at the same time. Sometimes it seems that culverts aren't identified or possibly in a failure mode when a new road is resurfaced. So once it's resurfaced, the last thing that the public wants to see or the maintenance department wants to see is cutting that new asphalt up to dig and replace a culvert. Another project we have here is Village of Gates Mill. This was in Cuyahoga County, Ohio. This was slip lining of 190 feet of 120-inch culvert. Existing culvert with 96-inch Weholite with welded joints. This was a private community, so the reline prevented heavy haul trucks in and out for all day for weeks. On a project like this, this had a deep cover over it, so there would be a lot of haul of material in and out to perform a dig and replace here. This project was completed in in 6 weeks, which is approximately about a third of the estimated time of construction for the open cut. Another project in Ohio is State Route 2 under Interstate 90, Cleveland, Ohio, Ohio Department of Transportation. The consultant on this project is Arcadis and Parsons Brinkerhoff. This was 1,000 feet of 11-foot diameter. This was the project that you saw earlier where the last 250 feet of pipe was required 2 bulldozers to be able to insert that, get that liner completed. And Parsons and Arcadis found this to be the most economical solution to this project. And here we have Route 88 in New York, Department of Transportation. These are a couple different liner sites. So they had 384 feet and 254 feet of 60-inch, 230 feet of 42, and 238 feet of 54. They completed, and this had welded joints as well. They completed in a day and a half 254 feet of 60-inch pipe. So pretty impressive to be able to rehabilitate that culvert and get ready for that in a day and a half. And here's a very important project. This is Canadian National Railway. The last thing, if anybody knows about railroads, they're very, very difficult and very, very conscientious of trying to shut the rails down. And it is very difficult to get to do that because of the length of rail. It has to be shut down at the time, just even for a small section. It just backs up. They were able to maintain productivity and of the railroad while using a culvert liner on the 54-inch here with threaded joints. And with this, they saw that they really have an opportunity to address their culvert situations and not cost them downtime on the rail system. And the last project coming up here for us is a project on I-70 in Parachute, Colorado. This was 1,500 feet of 40-inch Weholite pipe into 54-inch. This had welded joints as well. They wanted the DOT wanted to avoid the major cost of dig and replace. So for this long of a length, the cost savings is probably easily getting into that closer to that 50% range. So this reline resulted in a long-term economical solution for them. So to sum up a few things today that we talked about here, we want to ask you, don't dig it up. Slip line it with Weholite. It's up to 10 times faster in most cases. It prevents future pavement problems by not having to cut that pavement. It avoids traffic disruptions. You're able to maintain or increase flow capacity. It's an environmentally sound solution, and it saves money. And with all the DOTs and the maintenance departments always on strict budgets, we can help them save money while improving the life cycle of their existing culverts. And with that, I think I'll turn it back over to Faz.
Thank you, Mark and Joe, for a great presentation. Thank you to all the attendees for joining us today. If you have any specific questions for our speakers, please email them at mark.lister@uponor.com and joe.nagy@uponor.com. The questions you've asked during the webinar will also be answered and sent to you via email, as well as your PDA certificates that count as a 1-hour education credit. Again, on behalf of our speakers and Uponor, I'd like to thank you for joining.